In this video, we're going to create the game Tic Tac Toe using React. This is in your typical React Tic Tac Toe example. This one has an awesome UI, and I'm going to teach you how to build it. Let's go ahead and give the final game a try. As I move my mouse over the tiles, you're going to see that's going to let me know the current player's turn. So I'm going to put X down, and then it's going to show me O, then an X. And then every time I click, there's also a sound that you're hearing. And then if we win over here, it's going to play a little bit of music. It's going to let us know that X wins. It draws this awesome strike through over here. And we have a play again button. Pressing the play again button resets the game. And since this is a React application, we can easily take the tic-tac-toe component, duplicate it, and have as many tic-tac-toe games as we want on the screen at the same time, all managing their own state. This is Coding with Adam, and let's get to the code. If you enjoy my videos, please subscribe, like, and share. For the tic-tac-toe game, I'm going to be using VsCode on the left-hand side, and on the right-hand side, I'll be using the Chrome browser. I've also used Create React App to create the React application. However, feel free to create the React application however you like. In order to build tic-tac-toe in React, we need to think in components, and what better way than a component diagram? On the right-hand side, we have our component diagram, and this describes the different components that we'll be building for the tic-tac-toe game. To start off with, the first component that we need is the tic-tac-toe component, and that includes everything that you see on the screen over here. To build this component diagram, I had to take a look at the game of tic-tac-toe and figure out which components we would need. Looking at the game over here, we can see that one of the main root components is a board. Within the board, we have tiles. So going back to our diagram over here, we can see that we have a board, and then we have tiles, and there are 9 tiles to represent the different tiles that we have for our play area to place X's and O's. Another component that we have is the strike through component. The strike through component is the line that we draw in order to indicate a winning combination. The strike through component is used on our board, and since it's used on our board, we can see in our diagram that the strike through is inside of the board next to the tiles. The text that we have below our board is our game over text, and this indicates if a player has won or there has been a draw. In our component diagram, you can see that the game over text sits within the tic-tac-toe component below the board. So the board and game over text are technically on the same level as they're within the tic-tac-toe component. Finally, our last component on the screen is the play again button. In our diagram, I've called that the reset game or play again button. It's a component that's used to restart the game. And like the game over and the board, they all sit on the same level within the tic-tac-toe component. Now that we understand the diagram, we can get to the code. As we build the application, I'll be referring back to this diagram. I've started the application using npm start, and we have our default React application. We'll create a folder called components, and then we'll create our first component, the tic-tac-toe board. And I'm going to give the file a JSX extension. Not required, you can give it a JS extension if you like. The JSX is a good way of indicating that this is a component. And if you want these cool icons that I have over here, I'm using the material theme. So you can go to extensions and just search for material icon theme, and you can have these icons as well. Back to our tic-tac-toe component. As of React 17, you no longer need to import React at the top of your component file, so we can go ahead and create our tic-tac-toe function. And our tic-tac-toe function is simply going to return a div, and we'll put an h1 with text of tic-tac-toe, and then we'll export our tic-tac-toe component. We'll go to our app.js where we'll delete the default HTML that we have. We should see our screen refresh with any issues if we've deleted all of that. But then we're going to import our tic-tac-toe. And here's a cool little trick in VS Code. If you start typing the name of the component and you've done your export in tic-tac-toe, you can go ahead and just hit tab and it will automatically import that. So at the top, if that doesn't work, make sure to import your tic-tac-toe. We'll close up our component over here and save it, and you can see that we have our tic-tac-toe component on the screen. This will satisfy the first part of our component diagram, the tic-tac-toe board, the most outer component. Next, we'll go ahead and we'll create our board and then our tiles. We'll create the board.jsx. Now, creating these components can be a little tedious. However, there is an extension in VS Code that you can use to make this really quick. It's called Simple React Snippets, and it provides you with shortcuts. They'll create the boilerplate code for you. So if we go back to our board.jsx, I can type FFC, which stands for Function Syntax Component. I can hit Tab, and it gives us this function for us where all I have to do is type board, and it fills in the function name and it fills in the export for you. Now we're in multi-cursor mode, so you can just hit escape to exit multi-cursor mode. We'll create a div, and we'll just write the word board in there as a placeholder. And then we'll go to our tic-tac-toe game, and below our H1, we're going to go ahead and add our board. And as you recall, if we start typing board and we've done our export correctly, it will show us as a suggestion over here to import. We can hit tab, close that board, and it will import over here our board from the board file, and we can see board on the page. So if you're seeing this, we're in a really good state. In our component diagram, the next thing that we can create are our tiles. So let's go ahead and create our tile component. Under components, we'll go ahead and we'll create a new file called tile.jsx. We're going to do FFC from Simple React Snippets there and hit tab, and we'll call this tile. Hit escape to exit multi-cursor mode. We're going to add a div for now, and we'll just place an X for now as a placeholder. We'll go to our board.jsx, and we'll remove the word board there, and we're going to put tile, and because it shows up here, I can hit tab to automatically import that at the top of the file. So we have our tile here. I'm going to save. Taking a look at our component diagram, we can see that we need 9 tiles for our board. So let's go ahead and create 9 tiles over here. So I'm just going to copy and paste these, and you can do the same to duplicate them. So now if I click save, we're going to have 9 X's on the screen. Back to our component diagram. Within the board, the other thing that we have is our strike component. Let's go ahead and add our strike component as well. Create a new file. We'll call it strike.jsx. We'll do FFC again to create that component quickly. Then we'll go ahead and we'll just add a placeholder over here called strike to make sure it's going to show up on the page. We'll go back to our board, and after our last tile, we'll add our strike component, which is imported here at the top, and hit the component down here. And now we can see a strike on the screen. Since we're not using the strike component just yet, we're going to go ahead and just remove that placeholder text so that it's blank, but it will be here on our board. The next thing that we need to do is make our tic-tac-toe game look like a tic-tac-toe game. So we need to make our board look like this. In order to do that, we're going to be using CSS. Now in the description of the video, I've added the link to the CSS. This is called a gist, and it contains a single file in it, the app CSS. The complete project also has the CSS if you've downloaded the project. Now what you can do is you can copy and paste all of the CSS over here and put that in your project, or what you can do is follow along like I'll be doing over here. And what I'm going to be doing is only copying and pasting the CSS that we need as we need it, and then explaining it so that you understand what the CSS is doing. The first bit of CSS that we'll need is our body and H1. We'll go ahead and copy that. Then we'll go to our app CSS. We're going to remove all of the HTML here and replace it with the new HTML that we just added. Now you should see a change on the screen. The background should change and the text should be centered. If you're not seeing this, go to your app.js and there should be an import for the CSS. So this is how it works. Inside of the app.js, we have an import that is importing that CSS. If you're using the default project like I am, it might mention this logo over here. We can remove that as we don't need that. That's from the default project. And one real quick note, you might notice as I'm making changes in files, clicking save, that the file is automatically formatting. Well, you can do that as well too. If you install the extension called Prettier, it will automatically format your file as you click save. Now, to install it properly, you'll have to follow a few instructions, and you can check that out in my Prettier video. It'll it'll explain how to configure and set up Prettier. For our CSS, we've added CSS to our body. We're using a display flex. We're using a flex direction of column, which means we'll be stacking the items one on top of another. We're also centering them. We set a nice background color and the text is white. And the H1 is also simply being centered. Next, we can apply some CSS to our board and tile. First, let's jump to our board. On our div, we're going to go ahead and add a class name of board for our board. And then we'll jump into our tile and we'll add a class name of tile. Make sure both of those files are saved. Go back to our app CSS. We'll go grab the board and title CSS and we'll paste that into our CSS file and we'll see that CSS applied. And now we have a grid of X's. We have 3 across on each row. This is starting to look more like a tic-tac-toe game, and the way that we're achieving this is we're using a different way of displaying. So earlier we used flex to center items. Now on our board, we're using the display method of grid. And if you take a look at this template over here, we're using a grid template column. So we're saying for each column, make it 100 pixels wide. So we can over here, we have a column and it's 100, 100, and 100. And then if we look at the rows, we're also saying that each row is 100 pixels. So the height of each one of these rows is 100 pixels. And we define that 3 times, which means that there's 3 rows and there's also 3 columns. We've also updated our cursor to a pointer. So as we highlight over each tile, it changes to a pointer. Now as for the tile itself, we're setting the current color. Now this is a little CSS trick over here. It's basically using the current color, which is going to be equal to whatever color that we set in the body over here. So if I went ahead and changed this to red and saved it, the current color becomes red. So just a little CSS trick. Other than that, we're setting the font size to 2em. The display, once again, is going to be flex. And the reason we're doing that is we want this X to be in the center of each square. So we achieve that using the flex display. So a combination of flex and grid is what we're using to position our HTML elements. The next thing we're going to do is we're going to go ahead and add our grid lines to our tic-tac-toe game. From our CSS, we're going to be grabbing our bottom border and our right border, and we'll paste that into our CSS. We're going to be using these 2 CSS classes in order to draw our grid. Jumping into our board, for each tile, we're going to go ahead and add a class name in order to draw our lines. Let's start with the first tile. We're going to be adding a right border and a bottom border. Inside of the tile, we're going to go ahead and grab that class name that we're passing in. So we're going to go ahead and destructure it over here, grabbing our class name. We'll then go ahead and use a JavaScript expression over here. So we'll delete the tile and put curly braces. We're going to use string interpolation. So we're using the backtick next to the number 1 on the keyboard, and I'll replace that with tile. Then we'll use a $sign and replace that with class name. So effectively, we're passing in the right border and bottom border depending on the tile that we're on. And you can see when I saved it, it drew the bottom border and the right border for the first tile. Now we can go back to our board component and update the rest of our tiles. The next tile is going to be exactly the same, needing the bottom and right border. The third tile doesn't need our right border, so we can go ahead and remove that. Then the next row, we're going to need the right and bottom. The next one over, right and bottom as well. And once again, same pattern, we can go ahead and remove that right border. And then for the bottom ones, well, we don't need that bottom border, so we can delete the bottom border over here. And then we can copy this one and update it as well. So we only need the right border. And the last one doesn't need a class name at the moment because we don't need a right or bottom border. Now that our tic-tac-toe board looks really awesome, we can go ahead and focus on tracking the state of our application. The first piece of state that we're going to be tracking is our tile state. We need to know the value of each and every tile on our board. Jumping back to our component diagram, the place that we're going to be tracking our state is at the tic-tac-toe component. From the tic-tac-toe component, we can pass our state down into our children components, such as the board and tile. We'll jump back to our tic-tac-toe component. In our tic-tac-toe component, we're going to go ahead and import useState from React. useEffect. Then inside our tic-tac-toe component, we'll destructure out the tiles and set tiles from our useState. The default value that we're going to be using for our tiles is an array, and the array is going to be 9 items, and we're going to set all of those values to null by default. Next, we'll go ahead and we'll take our tiles and we'll pass that into our board through a property called tiles. We'll go to our board and we'll destructure out the tiles. Then for each tile, we're going to go ahead and add a value property. And from the tiles array, we're going to be grabbing the value. So for the very first tile, we're going to grab a value at position 0 inside the tiles array, which is the first item. Then we'll grab the second item, which is position 1. And then what I'm going to do is a little multi-cursor editing trick over here to paste the value in every single tile. On Mac, you're just pressing Command D while you highlight the word tile. And then on Windows, you hit Control D, and every time you do that, it's going to add another cursor. Then all I have to do is press paste. And then for each one over here, I'm just going to go ahead and change that value depending on the position in the array. So as you can see, we're just going up in value. And then the last one is number 8. Then we'll jump to our tile component. Within our tile component, we're going to go ahead and destructure out that value. And then all we have to do is replace the X inside the div over here with a JavaScript expression, which will be our value. Save that, and you should notice that all the X's go away as they're replaced with a null value, which will show nothing on the screen. If we go jump back to our tic-tac-toe where we set up our useState and we change that default value from null to X, you'll see it's X once again. If we change it to O, it will be O. We'll switch that value back to null, and we're going to add another piece of state. We're going to be tracking the player turn. So we'll add our player turn and set player turn, and we're going to make that equal to our useState. Now the value you want to pass in is either X or O. For the value of X and O, we're going to go ahead and create 2 constants, one for X and one for O, and we'll call that player X and set that to X, and we'll create one for O. And then for our player turn, we'll go ahead and we'll set our default value and we'll set that to X. The next thing we're going to do is we're going to handle on click. Every single time you click on a tile, we want to place an X or an O depending on the current player's turn. We'll start by creating a function called handle tile click, and we're going to make that equal to an arrow function. That arrow function is going to take an index to indicate which tile is being clicked. And what we'll do to start off with this is we'll just do a console log and we'll print out the index of the tile that was clicked. On our board, we're going to add a new property called on tile click. And we're going to set that to our handle tile click. On our board, we'll go ahead and destructure the on tile click. And then for each tile, we're going to add an on click and set that equal to an arrow function. And that arrow function will call the on tile click, passing in the array index, just like we do to grab the value. So we're passing in 0. Then we're going to copy this and paste this into every single tile. I'm going to use that multi-cursor editing trick that I mentioned before. Feel free to check out my video on how to use multi-cursor editing. Another trick I can do over here is because I have multiple cursors, I can actually copy multiple values and then paste those values in. So I can quickly set the array index for the on tile click method. Don't worry if you're not able to do the multi-cursor editing just yet, but it's a great feature to learn in the future. Then we'll go to our tile where we'll destructure out the on click. On our div, we're going to add an on click and we're going to make that equal to the on click that we just destructured. Now everything is wired up. We can go ahead and get our inspect and get our console up. And then when we click on these tiles, we're going to see that it's printing out the index. So if you're printing out all the numbers sequentially like this, you know that everything is working. Now we can go back to our tic-tac-toe component and to our handle click method. We'll remove the console.log, and what we're going to do is we want to place the current player's turn inside of the board when we click on the tile. And the way we're going to achieve this is we're going to start by making a copy of the tiles array, and we'll just call this new tiles is equal to a copy of the tiles array. Then within the new tiles array, using the index that we passed in, which will represent the tile, we're going to find the value that's here, change that value to the current player's turn. Then lastly, we just need to update the tiles. So we call set tiles and we give it the new list of tiles. Save that. Then we can go back to our board and we should be able to click in each tile. And because the current player's turn is always X, it's only going to be placing X's in the board. To get it to alternate between X and O, we're going to go ahead and check the current player's turn. And if the current player turn is equal to X, we're going to go ahead and set the player turn to player O, and otherwise we'll go ahead and just do the opposite and set the player turn to player X. So now if we go back to our board and I'm going to refresh the screen to clear it, I'm going to go ahead and click on each different tile over here, and you can see it's switching between X and O. One issue that we have is if I click in one tile, it's going to alternate between X and O. So to fix that, what we can simply do at the beginning of our handle click, we're just going to add an if statement that goes ahead and checks the value in the tiles index to see if it's not equal to null. If it's not equal to null, we're going to go ahead and just return. So if there's already a value there, don't allow any value to be added again. If I go ahead and click on this tile here and I click again, you can see the value is not changing and I can still click on the other tiles. The next fun thing that we're going to handle is that when you hover your mouse over the board, it shows you the next player's turn. We'll start by grabbing the CSS that we need. We'll copy the X hover and O hover, and we'll paste that into our app CSS. The way that the X hover and hover work is that they both have a :hover selector. What that does is it activates the selector when your mouse is over the element, such as our tile. And then the : after is going to be adding some content after our content, and that content that we're going to add is an X, and there isn't any content in these squares. The only thing is going to be an X or an O, and then X or O, we're going to be setting the opacity 2.4, which is going to make it look a little bit transparent. Let's go ahead and give this a try. Let's go to our Tile JSX, and for the time being, we're going to add an extra class over here. So we're going to add our X-hover, and then when we go over our empty squares, you're going to see an X. But if we also go over these squares that already have a value, now you can better understand how the : after works. So the current content in there is an O, and it's adding the X afterwards, and then it's applying the opacity 2.4, which, as I said, makes it look a little bit transparent. Then we can go ahead and just remove our X hover, as we want this to be dynamic, either showing the O or the X. And if there is an item already in the square, we'd prefer not to show that hover. So we'll jump back to our tic-tac-toe, and in our board over here, we're going to pass down the current player turn. So we'll go ahead and we'll add a new property called PlayerTurn, passing in the player turn. Then we'll go to our board, we'll destructure out the player turn. And then for each and every single tile, we're going to go ahead and add player turn is equal to player turn. Then we can do that for the rest of the tiles, just copying and pasting it, or using that multi-cursor editor trick that I showed you earlier. For this one, I do have to do one extra thing because this is on a single line. So I just got to hit enter, paste, put that in, and then just double check that every single tile has the player turn. Before we continue, I just wanted to mention that there is quite a bit of duplication between our tiles. As you can see, the only real difference is the index or the class name, and if you've already noticed this, congratulations. And of course, yes, you can improve upon this, and if you do, let me know in the comments. I'll give you one hint: the class name does change between the different tiles, so you'll need a second array to track that. And then we're going to go to our tile where we'll destructure out the player turn. We'll create a variable called hover class, and we're just going to assign that to null. Then we'll do an if statement to double check that our value is equal to null, which means that the cell is empty. And we also want to check that our player turn is being set, just in case we made a mistake on our board and we forgot to pass that in. So we'll check that it's not equal to null, and we'll go ahead and we'll assign a value to the hover class. We'll use string interpolation, so use the backtick, and we're going to pass in the player turn. On the board, the player turn is uppercase, so we'll need to make that lowercase, so we'll call to lowercase, and then we're going to add dash hover. Now we can go ahead and use our hover class below where we assign our class name. We'll pass it in. So if there is a value, it's going to have a value. Otherwise, it's going to be null. And then once we save, we can go ahead and try it out. So it's showing X. If I click in a cell, then the next player is O. So the hover is now perfectly working. Next, we're going to get the strike through working. We'll go to our CSS and copy and paste all of the strike CSS. And then we'll paste it inside of our app CSS. So we'll just go add it there. Now let's go ahead and try the strike CSS out. Now there are two classes that we'll need to apply. We'll jump to our strike component and we're going to add a class name and we're going to make that equal to strike. So going back to our CSS, there is a strike class, which is the base one that we always need to apply. It positions the line that we're going to be drawing at an absolute position. So somewhere within this board. And then we have our background color, which is set to dark orange. Now we select one of these strike class names. So let's try row 1. We'll jump back to our strike and we'll paste that in over here. So we have strike and strike dash row 1, and you can see that it strikes through the first row. If we change this to a 2, it's going to move that line to the second row, and a 3 will move it to the last row. We also have other ones for the column, and we also have 2 for the diagonal. So if we set this to diagonal, you'll see a diagonal line. Let me explain how this works. Let's start by changing our strike to a row. And as you can see over here, we're striking out the first row right across. Now, the way this works, as I said, there are two properties. One that's always going to stay the same called strike, which tells our element to be positioned absolute, which means it's going to be positioned relative to its nearest ancestor, which is the board. And then within the board, we can move that element on top of all the other elements within the board. So as you can see, we've moved this strike over here, which would be at the bottom on top of this row over here. And the way that we did that is with a second CSS selector. We used strike row 1, and strike row 1 in combination with the position absolute, we're using this property called top, where we can say position 15% from the top of the ancestor element, which is the board. So we're saying 15% from the top from here, which brings us down to over here. If we go ahead and look at row number 2, we're going 48% down from the top, which creates the line over here. And then for all the rows, you can also see that we're setting the width to 100% so that our line is drawn from one end of the board to the other end of the board. The columns are then very similar. So if we take a column as an example over here, column 1, and we take a look at our CSS, we're going to see that the column's height is 100% in combination with our position absolute on the strike. We're going ahead and setting the left position to 15% from the left, which will draw the line over here. And then as the columns get further away, we continue to use that left position. So once again, 48% and then 83% to draw that last one over here. The most complicated strike through is the diagonal. So let's go ahead and add an example over here. So we have our diagonal that goes across this way, and then we have a second diagonal that goes across the other direction. And the way that this works in our app CSS, once again, in combination with the absolute, we are using the top and left over here. So 50% from the top, which was just about the middle, and then 5% from the left. The real magic is the transform, where we skew the Y position. You can see for this one, we're using 45 degrees. And then for number 2, which is this one over here, we're using the opposite, which is negative 45 degrees. So if I were to change this to 45, that's exactly what we have for the first one. And this is what we have for the second one. So this is where the magic is for making that line appear diagonal. Now let's go back to our strike over here, and we're going to remove this value as it's going to be dynamically passed in. We can jump up to our tictactoe JS. We'll add some state for our strike class, and we're just going to make that equal to useState, and the default value will be empty. Then we'll go ahead and pass that into our board as a property. And on our board, we'll go ahead and destructure that value out. And then we'll pass that property down into our strike class component. And finally, we'll jump to our strike class where we're going to go ahead and once again destructure that value out. Then we can go ahead and update our class name where we're going to use string interpolation. So we'll use that backtick. We'll add strike back. We'll put a $sign and we're going to pass in that strike class. We can go ahead and test this out by jumping back to our tic-tac-toe, going to that useState, and we're just going to add strike row-1. And if you have a strike through, that means it's working. We'll go ahead and remove that test. And the next thing we're going to do is we're going to go ahead and check for a winner. The way we're going to do that is we're going to be using a useEffect. So if we go to our imports over here, we're going to add useEffect. Within our tic-tac-toe component, we're going to go ahead and call useEffect. We'll pass in an arrow function, and our dependency list is going to include the tiles. Every time the tiles change, we're going to go ahead and call check winner. Check winner is going to be a function that we're going to define outside of our tic-tac-toe component. And we'll just do a little test to make sure this works by putting a console.log of check winner, and we'll save that. And then we'll go ahead and open up the developer tools and open up the console tab. And every single time that we click on one of the tiles, we should see the text over here, check winner. And we know that this is working. To determine the winner in tic-tac-toe, you need to get 3 in a row. And the way we're going to be determining the winner is by creating an array, which is going to have all the winning combinations. We'll call that array winning combinations. Inside of this array, we're going to go ahead and define an object that contains the winning combo and the strike class that we should show. Let's start by defining our rows. The first object is going to have a combo, and that's going to be an array. Now this array is going to be the index of the 3 tiles that we should check for a winning combination. For the first row, the very first tile is at position 0, the second tile is at position 1, and the third tile is at position 2. So all we have to do is fill in our array with 0, 1, and 2. And then if that is the winning combination, we're going to have a strike class value, and that's going to be equal to strike row-1. For the next row, we can duplicate that line, and this tile over here is at position 3, so we can put a 3 over here, and this one is at position 4, and this one position 5. We can see that if we go 0, 1, 2, and then 3, 4, 5. So 3, 4, 5 is what we have here. And then we'll go ahead and update the strike class. So it's strike row 2, and then we'll duplicate this line again. And as you can imagine, the next number here is going to be 6, 7, and 8. And then we'll update the class to strike row 3. Next, we can go ahead and figure out our columns. We'll go ahead and we'll just copy the first line there. Now to figure out the columns and the numbers we have over here, what's really cool is by doing the rows, we actually have all the indexes in front of us. So 0, 1, 2 represents this top row, 3, 4, 5, this row, and 6, 7, 8. So if we want to know the numbers for this column over here, take a look over here and we see that it is 0, then 3, then 6. So we just update our numbers over here to 0, 3, 6, and we change our strike class from row to column. Then we go ahead and duplicate that. So I've just duplicated that twice. Now to figure out the next column, that's the middle column over here, we can look at these numbers once again. So it's going to be 1, then 4, and then 7. For the last one, it's going to be 2, 5, and 8. So we'll update those numbers over here, 2, 5, and 8. And we'll update our strike class to column 3. Lastly, the diagonals. We'll just go ahead and copy one of the columns. Now for the diagonal, we'll start with the first one, which should be 0. Then the second one will be 4. And the last one will be 8. And we'll change the strike class, so it's diagonal-1. And then we'll add our second diagonal. Our second diagonal is going to go across this way. So we'll start with the lowest number, 2, and then 4 is the same, and then 6 is its ending point. And we'll just update the strike diagonal to 2. Now we can go ahead and implement our check winner function. As you may have noticed, the check winner function is outside of the tic-tac-toe component. You could leave the check winner function inside of here. However, I moved it out as it could be tested separately if we wanted to. Back inside our tic-tac-toe component, we're going to pass along the tiles and set strike class to the check winner function. Inside our check winner function, we'll go ahead and accept those parameters. We'll delete the console log, and to check for the winner, we're going to be looping over our array of winning combinations. We'll use a for loop. We'll do a const winning combination of winning combinations, and then from our winning combinations, we're going to go ahead and destructure the combo and the strike class, and we'll make that equal to our winning combination. We could also destructure right over here if we wanted to, instead of doing it on the next line. Let's go ahead and do that little refactoring now. So instead of destructuring right over here, let's just destructure that value out right away. Our combo represents the position of the tiles that we want to check for winning combination. And the way we're going to do this is we're going to extract those 3 values. So we'll get tile value 1, and we're going to make that equal to tiles. Then we're going to pass an index in, and we're going to get that from our combo array. So we're going to get the first value. And let's take this one over here. Combo with 3, 4, and 5. So we go 0, 1, 2, 3. 3 is going to be over here. We'll pass 3 into tiles, and that's going to give us O. Then let's do the next 2. We'll get the second value and then the third value. We'll pass 1 over here and 2 over here. Now for this one over here, when we look for the second position in the array, we're going to get 4, which will be the X over here when we check the tiles array at position 4. And then we're checking for position 5 over here. When we check for position 5, we pass that into the tiles and we get an O. Then we can go ahead and check if all 3 values are the same. We'll do an if statement, and we're going to check if tile value 1 does not equal to null, and that tile value 1 is equal to tile value 2, and that tile value 1 is equal to tile value 3. If they are equal, we can go ahead and set our strike class by calling set strike class and passing in the strike class that we got from our winning combination. And when we save, you see the strike through for the winning combination that we have on the screen. Let's try this out again to make sure our rows and columns are working. So let's go ahead and get a winning combination at the first row over here. Then I'm going to refresh and get a winning combination for one of our columns. So our center column now has a winning combination and the proper strike through. Back to our component diagram, the next thing we're going to implement is our game over component. The game over component is displayed when a player wins the game or there is a draw. We'll go ahead and create a new component called gameover.jsx. Inside of here, we're going to use that ffc command to create our game over component quickly. And then we'll just add a div over here where we'll just put game over. Then we'll go to our tictactoe JSX, and below our board, we're going to go ahead and add our game over component. We'll save that and just make sure that it displays the correct text on the screen. The game over component is a little bit complicated as there are times when we don't want to show it, times when we do show it and it's either going to display text that says it's a draw, X wins or O wins. And to help us better manage this, we're going to create a brand new object called GameState. We'll create a JavaScript file called GameState.js. This GameState object will be similar to that of an enum in other languages and will contain 4 different states. Player X wins, which we'll go ahead and assign a value to, and we're just going to set it to 0. Player O wins and assign that to another value, and then draw and assign that to 2, and in progress and assign that to a value 3. The reason that we assign these to values 0, 1, 2, 3 is that we wanted them to be unique. We could have also just taken the name and then assigned that to a string. However, I found this is a little bit simpler and kind of copies what an enum would do in other languages. Finally, we just need to go ahead and export our game state. We'll go back to our tic-tac-toe component and we're going to import our game state. Inside of our tic-tac-toe component, we're going to go ahead and add some new state to track our game state. So we'll add the game state and set game state, and we'll make that equal to useState. The default value will be our game state.inProgress. We'll then pass our game state into our game over function. Inside of game over, we're going to go ahead and destructure that value out. And we're also going to go ahead and import our game state. Inside of our game over function, instead of having this return statement, we're going to switch this to a switch. And for the switch, we're going to pass in the game state that we destructured. Then we'll set up cases for each one of the game states that we can be in. So if the game state is equal to in progress, then we're going to go ahead and just return empty, as we don't want to show anything on the screen. And we can see that our screen is already updated and nothing is showing for our game over. The warning that I have over here is letting me know that I should have a default case. That warning is coming from ESLint. We'll just go ahead and do the same thing that we do for in progress and return nothing. The next case that we're going to go ahead and handle is our player O wins. And for that, we're going to be returning a div. We'll apply a class called game over. And for the text, we'll put O wins. The next case is going to be very similar, and we're going to handle X wins. We'll change the value over here to X and the value here to X as well. The very last case that we're going to handle is draw. And for that text, we'll just simply put draw. Before we test this out, let's add our game over CSS. I'm going to go ahead and copy this, and then I'm going to go to my app CSS, paste it in, save it. Then we're going to go to our tic-tac-toe, and within our tic-tac-toe component, we're going to go ahead and update our default state to test this out. We're going to switch from in progress to player O wins, and you should see this nicely laid out game over text for player O wins. We'll switch this to player X wins to see if that works, and yes it does. And then we're going to go ahead and try the draw out, and that works as well. And if we switch back to in progress, we should not see anything, and there we go. Now we can go ahead and use our set game state. We're going to be passing that into our check winner. Inside check winner, we're going to go ahead and accept that parameter. Then when someone wins the game, we can go ahead and set the appropriate state. So we'll check the tile value, and we're going to determine if that tile value is equal to X or O. If it's equal to X, that means the X player won. If the X player won, we'll set the game state to reflect that. So we'll say X wins, and that will set it to X. Then inside the else, the only other thing that could have happened is that player O won. So go ahead and just copy that, paste it, and change this to O. Let's go ahead and test this out. So I'm just going to make X win, and that works. Then let's test the game over text for O. So I'm going to make O win, and that works as well. The next state we're going to deal with is draw. As you can see, I have a draw over here, and there is no game over state. So inside of our check winner, outside of the for loop, so I'm going to collapse the for loop, and right after for loop, we're going to do our check over here. We'll do this check by adding a constant called are all tiles filled in, and that's going to be looping over every single tile using the every method, which takes in an arrow function. The parameter is going to be a tile, and we simply need to check that the tile is not equal to null. If this value is true, that means we have a draw, and we can set our game state to draw. And once I save that, we'll see that we get our draw game over text on the screen. There is, however, an issue, and I'll go ahead and show you what this is. I'm going to fill the entire board, except we're going to have a winner. So right now, you can see that it says draw when X has 1. In order to fix this, we just go to our for loop over here where we check for the winner inside of the for loop. If we found a winner inside this if statement, we're going to go ahead and return. And by returning, that's going to say the correct text of X wins because we stop executing over here and don't execute the check for a draw. Using our game state, we can also solve another issue that our tic-tac-toe game has. If we get into a winning state, you can see that I can still click on tiles. So once we get into a winning state, we want to prevent that. And the way we can prevent that is inside of our handle click. The very first thing we can check if our game state value is not equal to game state.inProgress. If it is, we can go ahead and return, which exits this method. Otherwise, we continue executing the method as usual. Let's go ahead and test this up by refreshing the game. Let's get into a winning state. Then I'll go ahead and try clicking the other tiles, and as you can see, I can't click them. Next, let's go ahead and implement our reset component, which is going to be the button that allows us to play again when it's game over. We'll start by creating a component called reset.jsx. We'll use FFC to stub out the component. We'll call it reset. We're going to create a div, and inside that div, we'll just put reset. We'll go back to our tic-tac-toe. Below our game over, we'll add our reset component. I'm going to hit tab to automatically import that. We can scroll to the top over here to double check it's been imported. And then I'm going to save, and we should see reset on the screen. Let's jump back to our reset component now that we know it's working. We're going to change the div to a button. We're going to add a class name equal to reset button. Then we'll go and grab our CSS over here for the reset button, and we're going to paste that into our app CSS. And now our reset button is styled. Our reset button should only be displayed when it's game over. We'll go to our tictactoe JS, and we're going to pass the game state to our reset component. We'll go to our reset component, and we're going to destructure the game state. And the first thing that we're going to do inside our reset component is we're going to check if the game state is equal to our game state.inProgress. As you saw over there, I did an auto import. So make sure to import this if your auto import didn't work. And then we'll just return if it is in progress. And now when I refresh the game over here, you can see there's no reset button. However, if we get into a game over state, then the button will display. Let's jump back to our tic-tac-toe component. We're going to add a method over here called handle reset. We're going to make that equal to an arrow function. For now, we're just going to put a console.log reset so that we can check that it's working. We're going to scroll down to our reset component over here. We'll add an on reset. Make that equal to the handle reset. Then inside of reset, we'll go ahead and destructure out our on reset. On our button, we'll finally add a click event, and we'll make that equal to on reset. We can open up our developer tools and go to the console. And we'll just double check that reset button is printing to the screen. If it is, we're in a good state. We can go ahead and implement it. Let's jump back to our tic-tac-toe component and find the handle reset method. We'll start by setting the game state back to in progress. Then we'll go ahead and we'll set the tiles and reset all the values by creating a new array with 9 items inside it, and then filling all of them with the value of null. Then we'll go ahead and reset the player turn back to the X player. And lastly, we'll remove the strike class by setting it to null, and we'll save that. Now let's go ahead and click the reset button. And when that happens, it reset the board, removed the strike, removed the game over text, and also removed the reset button itself. Let's go ahead and just try that out one more time. X wins. It shows the game over text and the reset button. And then we go ahead and click reset, and the game is reset once again. The very last thing we're going to do is add sound to our game. In order to do that, we're going to right click on the SRC folder and create a new folder where we're going to add our sounds. We'll call it sounds. Now you can find the sounds in the complete project, or you can find them over here inside of the gist. I've added a little comment where I uploaded the files as .movie files. Now there's the click sound and the game over sound. When you download these files, it's going to have this strange name over here. You'll have to rename it to match what's in the project. I'm going to go ahead and drag those files into the sounds folder. So we have a click sound and a game over sound. These files can be renamed to .wave instead of .move, and when you do that, you're actually able to play them within the VsCode project over here by clicking the play button. We'll jump back to our tictactoe JSX, and the first thing we need to do is import our sounds. We'll write an import statement like we usually do, and we're going to assign the first one to game over sound asset, and we're going to take that from, since we're in the components directory, we need to go up one directory and then down into the sounds directory. So to do that, we're going to do ... Then we're going to go ahead and go into the sounds directory, and then from the sounds directory, we're going to get the game over .wave, and we'll do something similar for our click sounds. We'll do an import for click sound asset, and we're going to get that from the same location, and the file name is click.wave. Then I'm going to go ahead and use our imports. We'll do that by defining a game over sound object, and we'll make that equal to a new audio object, passing in the game over sound asset. So the first thing we're going to do with our game over sound is we want to tweak the volume a little bit and lower it. So I'm going to set that to 0.2. And then we'll go ahead and we'll grab our click sound. We'll make that equal to a new audio object, taking in the click sound asset. Then I'll take our click sound and I'll set the volume equal to 0.5. In order to play our click sound and game over sound, we're going to be using a useEffect, and we're going to use one useEffect for the click and one useEffect for the game over sound. The useEffect for the click sound is going to work as follows. We'll define our useEffect, we'll pass in our arrow function. Now we're going to do an if statement over here, and we're going to do tiles.sum, passing in an arrow function. And we're going to make sure that at least some of the tiles are not equal to null, which basically means that there's a value on the screen. If there's a value on the screen, like an X or an O, then let's go ahead and play that click sound. Otherwise, it's going to end up playing the click sound as soon as the board loads. And then for this useEffect, we're going to need a dependency, and the dependency that we're going to have is on our tiles. So technically, you could possibly move this code over here, but it just looks a little bit cleaner in its own useEffect. Let's go ahead and try that out. Every time I click on a tile, you're going to hear a click sound. Lastly, let's go ahead and add our game over music. We'll create another useEffect. That useEffect will take in an arrow function, and then we're only going to play our game over music if it is game over. And there's only one state that we need to really check over here. So if it's not equal to in progress, that means we're in a game over state, and we can check whether or not we can play the sound. So right over here, that means we're in game over. So we go game over.sound.play, and this game state over here is going to have a dependency on the game state object. Let's go ahead and test that out. And there you go. We have our click sounds, our game over music. We're able to reset the game. And if we want this to match the demo at the beginning, we can rename our reset button over here to play again. If you enjoyed this video, smash that like button, click subscribe, and hit that notification bell.